Okay. I think we should be good now. I think people will be in here now. Oi. Sorry, guys. I was technology inept, and we should have everyone in here now. So we should have everyone back. And let me go back to our channel here. Okay. There we go. Let's do a clap test. 1 1000, 2 1000, 3 1000, 4 1000, 5 1000. Okay, good. We're good. Let me send this out. I'm very sorry, everyone, that this took a moment. I just noticed we were on like a huge delay, and that would not work for Kahoot at all. New Kahoot broadcast. Okay. Link here. Okay. And we should have it. Thank you guys so much. Okay, we got 8 people now. We got everyone. Oh my god, wait. Oh, am I just displaying the Kahoot code? Because I don't have the block. Why is that not on? Oh, shoot. We're going to get trapped. Ay, ay, ay. Oh, no. Okay. So here we are. Let's go ahead and let's start taking a look here. Let's wait for everyone to get in here. We've got the Kahoot code. Ay, ay, ay. Comedy of errors today, guys. I'm sorry, my brain's like... Here we go, let's pull that up. There we go. We got everyone in. We got 25 watching. Let's go ahead and cross our fingers. A little bit of a short Kahoot, and then we're going to go straight to talking about the practice test. So we're going to do a lot of good stuff here. We got 25 people watching. Let's start doing some reviewing. So ask those questions when you have them. Sorry for the delay. I know we were playing for 5, but then Brian can't YouTube. He's got to get better at this pro YouTubing stuff. But go ahead and ask me questions, and then we're going to head over to the practice test. We're probably going to go for probably till about 7. So ask me those questions when you have it. We're going to do some sampling review to start. So let's get everyone started in here, starting with the Kahoot. A little bit of a short Kahoot. We'll have a longer one for next one, and I'll make it work. So here we are with the first Kahoot question. A researcher selects their sample based on the percentage of highway, country, and city roads. A researcher selects their sample based on the percentage of highway, country, and city roads. I'm going to do one thing real quick. Sorry, real quick. We're going to take off that block and bring this back. So they're selecting based on a percentage. Now this is key right here, that's based on a percentage. So think about this. You would then sample randomly within these right here. Good, we only have a 4-second delay now, which is awesome. So what do we do when we select based on percentages? Ooh, we see a lot of people saying cluster. Now remember, as we talked about today in class, it's not a cluster sample unless you take all of them. So if you were to take every single highway road, every single country road, every single city road, that would be a cluster. But we're not going to do that. So ask the questions when you have them, because we're going to talk about each one of these sampling methods here again. Make sure you guys have it down. But this would not be a cluster. It would be stratified. I'm also going to turn off this welcome message. There we go. Okay, let's continue on. Get a drink of water. I missed the first question. No, I'm sorry. He never stops. But here we go. We got question 2 with an Amazon monkey in the lead. Amazon monkey. A researcher selects the first 20 roads next to their house. What kind of sampling method is this to select the first 20 roads next to your house? So you're just going to go out, you're going to take those first 20 roads. Looks like a bunch of people are getting this one, because this one's a pretty easy one. Hint, it's pretty easy to take the first 20 roads next to your house. I started setting up the YouTube event at 4:30, and things were just not working. Like my OBS, my open broadcast software had the wrong codes and all this stuff. So we got it working. And this is a pretty easy one because it is convenience. It's very easy. You're just going out and getting the first 20 roads. You're putting the survey online. This is a convenience sample. Next, let's see here. I'll give a prize to the winner. We'll bring a prize tomorrow. A researcher selects every 5th road on the listing of roads. Now, they would choose a random starting point. That's kind of key to this. They're going to choose a random starting point and then select every 5th road. So every 5th road will be selected from a random starting point. So what are we looking at here when you take every 5th road from a random starting point? Let's think about that. 5th road from a random starting point. Well, it's not multi-stage. Don't think it's multi-stage. You're actually incorporating what you have to by taking a random starting point, and you are taking a systematic sample. Nice job. Everyone realizes systematic has two key aspects. One, take a random starting point. I like that right there. And two, you will then select every kth item. Let's continue on. And remember, ask those questions when you got them if you need clarification. It's kind of a quicker Kahoot. I had a longer one, but we didn't have that material in this test, and I didn't have that Kahoot ready, and I'm sorry, but next test, I'll have a much bigger Kahoot, and things will start on time. A researcher lists all the roads and randomizes the order, then selects the first 50 roads. Now, this one's kind of a trick one. This one's a little tricky because the researcher lists all the roads and randomizes them, then selects the first 50 roads. Yours is barely loading. Definitely watch the Kahoot via the broadcast and then answer on your phone however you want. A researcher selects the first list, or excuse me, a researcher lists all the roads and randomizes the order, then selects the first 50 roads. This is a simple random sample. In a simple random sample, we enumerate everything in the population and then we select randomly. So remember, clustering is when you take a whole bunch at once, and stratifying is when you acknowledge a difference. Convenience is a very easy way to sample. Is anyone else having any problems, or is it running pretty smoothly for everyone? We've got some thumbs up in the chat. How's it running? How's it looking? Going pretty well? It seems like we might. Sure, it's stratified. And I think we, the first one was stratified. Stratified is when we talk about, like, let's take a certain amount of city roads, country roads, and also maybe, I'm trying to think what else, highway roads. So if you were to take country roads, highway roads, and city roads and take them by the percentages they are in the population, like think about Knoxville, we probably have maybe 30% city roads and 40% or 50% highway roads, and then 20% back roads. So you'd get, 20 back roads, 50 segments of highway roads. So you want to make sure you represent them. So when you stratify, you say, okay, each road is kind of different if it's a country road, highway road, or city road. And what we're actually collecting on for these roads, hint for a later question, is the number of potholes in the road. Does anyone have any idea if we're collecting the number of potholes in the roads? What that would be? So just say it in the chat. Give you guys some extra credit, 50 points extra credit now. If we collect the number of potholes in the road, what is that? Like, what is that? What is the definition of that? I've added a few mods here, I think. So what if we collect on the number of potholes in the road, then what is that? Well, no, we're interested in the number of potholes there are on the road. We'll do this one, but taxpayers' burden to bear. I like that, Evan. Here, let's go and let's take a look. We'll see this question coming later up, and you'll get the question for it. It might be next, who knows? A researcher is unable to get information from certain roads they select. So they kind of try to go out there and get information from these roads, and they can't get it. They just can't reach the roads. They just can't collect data on it. So if they can't collect data on the roads, what is going on? What do we have? What kind of bias is there? And when you think about the definitions here, we have response bias is when the bias is in the response. We didn't even get a response. Undercoverage is when we don't reach certain parts of the population, probably due to the sample frame. But the answer is non-response bias. It's non-response bias because we couldn't get info. We had them in our sample frame, and maybe someone could argue we didn't have access to them. The idea is still here, at least in my mind, so I'm not loving this question because there's a little bit of a disconnect. It's that we said, here's a road we're interested in, and then we couldn't get to it. And when I conceived this question, I thought maybe there's a lot of potholes in that road, like it's a really worn down, horrible road, and we can't get to it. And because of that, it's kind of non-response. We didn't get a response. We just say, oh, we didn't collect data on this. We still, that might lead to undercoverage. We might undercover city roads or country roads or some sort of roads we can't get to, probably more likely country roads. So I don't really love this question because obviously there's a little bit of a disconnect. I think of it more of a non-response bias because we weren't able to get the responses. Like we're unable to get those responses. Basically put, there's no way to get those responses. And so those responses that we could not get differ than the responses we could get. and that's a non-response bias. Undercoverage bias would be if we didn't have enough country roads, we didn't have enough city roads. But yes, so this one's a little tricky, probably one of the trickier ones on here. Let's see, what do we have next? The roads that the researcher samples, and this is a nice and easy one here. I put the 30 seconds on the block because we were on a 5-second delay. I'm so glad we fixed this delay. It's like a 4 or 5 second delay. Before it was like 20 seconds, and you guys wouldn't even hear the question or see it. It'd be halfway through, and we'd be like, where's the question? I just forgot to change one setting. One setting. And that's what took another 5-6 minutes to get back, restart the stream. And thank you guys for joining in. And I appreciate you guys not being like, Brian, you're horrible. I think Raul, you're 99% sure you're in our class. I'm going to pull up here. I'm just going to 99% sure. Like, I see all the names, and I'm like, I think that's one of ours. If so, a nice job. The roads that the researcher samples is the sample. And Raul, I think you are one of our students. Raul, I just want you to tell me in the chat, because I'm 99% sure, but I want you to tell me what was one of the activities we did in class, and that'll prove you're a student. Just tell me if you tell me one of the activities, only Raul, tell me one of the activities we did in class, and I'll make you a mod. Because I'm 99% certain I just don't want to make someone a mod who's not a student. But yes, so the roads, oh, cool, I'll give you, yeah, there we go. There. Cool, Raul, you're mod. There, I know who you are now, Raul. So you sit on the right side of the class. Awesome, thank you, Raul. So the sample is the roads we actually collect data on. So please ask any questions when you have them. I'll answer all direct questions, but the roads we actually get are the sample. You'll see the sample frame here in a moment, and let's see, maybe it's here. The researcher is collecting, ooh, this is one I brought up previously, and I'll go back to that, Evan, right after this one. The researcher is collecting the average amount of potholes per mile. So the researcher is collecting the average amount of potholes per mile. Do not start going crazy, Raul. So if we're collecting on the average amount of potholes per mile, what are we collecting? What are we collecting here? What would this be? The average amount of potholes per mile is the, and you guys should know it, it is the parameter of interest. And a key thing right here, I saw Evan asked, wouldn't that be the sample frame? And the sample frame is the people or things we have access to sample. So if we have access to sample something, and by virtue of us kind of knowing it exists, this kind of gets into some more theoretical things. We talked about a sample frame with going to the library, and in the library, you could access those students. So you'd be able to access the students in the library, and those students would be the sample frame. But the students who speak to you in the library are your what? The students who actually speak to you in the library are your what? The students who speak to you in the library are your what? Should see some people saying it in the chat. Maybe we'll do that as a final thing. Awkward Ginger, maybe we'll do that then. It is the sample. The students who actually speak to you are the sample. So does that make sense? The students who speak to you are the sample, but the students in the library are your sample frame. So the roads we have access to are our sample frame. And you might say by virtue of us knowing they exist. Like we have a list of all Knoxville roads, which I think is the way I worded it. That would be the sample frame. Now, if we can't get to the road, I kind of consider that non-response bias because we can't get a response from it. And then the sample would be the roads we actually collect data on. Like that's our sample. We got data from this row, from these roads. So I hope that kind of clarifies right there the difference between sample, sample frame, and parameter of interest is what we are collecting on, the quantity or quality of the road. In this case, number of potholes or average number of potholes. Mighty Oryx, I think that's how it's said, is coming up here in the lead, and Eager Rhino. So interesting how it's just round. A researcher decides to take 5-mile segments of roads and sample each 1-mile segment within. So they're going to do a cluster. Oh God, no! They're going to do a census. I just gave away the answer. They're going to do a census of this cluster. If you don't get this one right, I'm sorry. You answered too quickly then. But I don't know why I freaked out. It's not that big of a thing to give away a Kahoot answer. At least I gave away the right answer. But they're going to do a census of this cluster, and that's what you do. No, grind. It's not that. They're going to do a census of this cluster. And we know we randomly select. You're welcome, Saeed. We randomly select 5-mile segments. You only have so many characters to write a Kahoot question, but you would randomly select 5-mile road segments, and then you would do a census on that cluster. So randomly select your clusters, like we would take random bags like from today, and then you would do a census on that cluster. Like you would sample each 1-mile segment within that 5-mile segment. And think about this. If you're a construction person and you want to see what the quality of the roads are, or TDOT, I guess, you would drive out and you could maybe take 5-mile road segments to say what is the quality of each 1-mile road segment. And that's why cluster kind of helps. It's not really convenient. It's clustering. It's taking groups of things at once. So that is definitely a cluster sample, and it's not stratified because we're taking different 5-mile road segments. And we consider every 5-mile road segment to be like, here's a 5-mile road segment, here's a 5-mile road segment. They're each clusters. They're groups of roads. So the researcher takes too many city roads in their sample. They're taking too many city roads. What kind of problem do we have right now if they have too many city roads in their sample? With too many city roads, the problem we would run into is what? Let's see. I think this one's pretty good, pretty easy. If we have too many, it's kind of an obvious one when you think about it. Just break it down. Like, if we have too many, then did we do it an easy way? Well, we might have, but probably if we have too many city roads, it was probably due to us undercovering, so you have the answer right now, the other roads. So it's under coverage. Now remember response bias. Response bias, I don't think I have a response bias for this one. Maybe if the person collecting roads doesn't understand the definition of a pothole, then there might be response bias. Like if we say a pothole is anything larger than maybe like, I don't know, 10, 20 centimeters. I don't know how big potholes are. And they think a pothole has to be 50 centimeters. And they come back to us and they say, there are no potholes. It's because of the way we collected data. And then when we go and publish our results, they're like, what are you talking about? Because Knoxville has a different definition of pothole than what we used. So that would cause problems, and that would be response bias. All of the responses we got are biased because we didn't collect them properly. So response bias is when the bias is in the response. But if we take too many of something, we undercover something else. So you don't want to take too many city roads. You want to take the right amount of city roads. And what's a really good way to stop undercoverage bias? Like, what's a good way to fight against undercoverage bias? You could use this method of sampling to fight undercoverage bias. Who's got it in the chat for 50 points up there? So what's a good way to use a sampling method that could stop undercoverage bias? Any ideas in the chat? We've talked about it a little bit today. It's stratified wary traveler. Stratified is correct. We can stratify, and that will make sure we get, a certain amount. As Ivy says, strata right there. Let's go right here. Let's make another mod, and my light just turned off. Add mod right there, and there we go. Cool. A little bit of light. So stratifying. So the reason we'd stratify is then we could control. We could say we need to take so many country roads, so many city roads, so many highway roads, and that's stratifying helps. Stratifying would control and have us make sure we get the certain groups in our sample. So stratifying would definitely help to fight undercoverage bias. I'm trying to think, we're running low on Kahoot questions. We only got 2 more. The list of roads the researcher has access to. So this is a review question now. Good times to understand the questions. These are the roads we have access to sample. And it's kind of the ones we know that exist in Knoxville. Like we're saying, here's all the roads in Knoxville that exist. So we got a list of roads in Knoxville. And we would think we would have access to them. If we can't get to them, that might be some non-response bias. But these are the roads we believe that we know are in Knoxville. So what would this be? If these are all the roads, and we're not going to go to all of them, we're not going to do a census. These are the roads that are in our sample frame. And actually, and so why would it not be the population? I saw a lot of people answer the population here. Why would this not be the population? It's kind of a key thing right here. This would not be the population because, I want to see if anyone online can explain it. It just takes a half second here. Maybe I'll explain it. So feel free to type in the chat and kind of think it out. This would not be the population because there might be roads in Knoxville we don't know about, and they wouldn't be on our list. So the list of roads we have that we're going to choose from, that is our sample frame. Now, theoretically, it could be the population also. And exactly as Rule says, the population is all the roads. So we might have roads we don't know about, or roads that we, don't know, we don't have access to, so we just don't even put them in our sample frame. Like, we can't get to this road. It's a private road. If we want to talk about the road quality in Knoxville, maybe there's a road that's goes to somebody's house that we can't get to. Oh no, I'm sorry, wary traveler. I hope you didn't lose your streak. But you know what? We'll try to have one more question you care about here. One more question here. So, Soaring Yak. It's an awesome name. The roads the researcher wants to understand. Don't get too drunk with the power roll. So, the roads the researcher wants to understand. And you should definitely get this one now. Great review question also here. Got a lot of people chiming in, and that pencil's like super high def, at least on my screen. So these are the roads they want to understand. Remember, the parameter of interest was how many potholes are in the road, or the average number of potholes. Where the sample was the roads they took, the sample frame was the roads they had access to, and thus the population is the roads they want to understand, which might be all Knoxville roads. That would be the population. I know this was a little bit of a quick Kahoot. The next one will be longer with about 30 questions and a little bit more difficult. Do we know who Eager Rhino is? I'll bring you in a prize. Who's Eager Rhino? Who did it? And they destroyed it. I do wish we could use the names. Wow, they did really well. Eager Rhino. Yes, it's me, Tom Brady. Well, Tom Brady, you'll have to... do we have a Tom Brady in the class? It'd be funny if someone just randomly online joined our Kahoot and just destroyed it. So, well, we'll have to figure out who Tom Brady is, or an Eager Rhino is. I'll trust you guys as long as I'll bring in some prizes tomorrow for first, second, third. Come up and speak to me, as long as we don't have 10 people come in and be like, I won the Kahoot. But let's hop over to the practice test over here. And so we're going to hop over. I swear I put the code in the thing. I must have not hit save. I think I'm losing my mind, everyone. Slowly but surely. And you guys are right. I did not hit save on this. I'm going to bring up the key since it has the answers, and we're going to kind of talk through this. Now, this is the key right here, and I want you guys to ask any questions you have about the key. We should see everything here. And we're just going to go over some of the key questions here. So please, at any point, if you have questions about this, and this is kind of a good review, please ask questions. So with this, can we do number 4? Yeah, let's jump right to number 4. I like that. And I think, did you email me, Evan, about number 4? I saw right before the review, I had some questions. It was like literally the moment before the review. So let's do number 4. And this is some normal curve stuff. So great stuff right here. Okay, so when we look at the 75th percentile on the normal curve, what we should automatically do, we can do mosaic next, yeah. We'll go back to that. We'll do number 4, and we'll take all questions you guys have, and we can do the other one a bit too. I'll stay here for probably about another hour or so we'll just keep doing questions. The reaction time of a professional hockey goalie was measured many times, and the distribution of these reaction times had an average of 150 milliseconds with a standard deviation of 10. And what you should see here is we've got all these different curves, and they all have the right numbers. That is the first thing, got the hiccups, the first thing I would check right there, and they all look to have the right numbers. Now we're going to see different stuff. Whenever you're presented with these curves right here, I want you to notice what percent of area is shaded or what's going on. This is 75% on the outside. This is 25% on the inside. These curves give you redundant information. Does everyone see how this one and this one are identical? You really can't glean much more. And what I would actually do is, if I was taking this exam right here, I would write 37.5% in here. I would write that into here and use this space right here to write 37.5. So that would really help. And when we go down to these curves, let's take a look at what we have. 75% is inside of here. You can see that from right here, 75%. So what percent is in the lower portion? What percent is in the lower portion of this curve? Like right here and below, this white area is how much of the curve? If 75% is in the middle, we do our trick where we go 75 in the middle, 25 outside, and 12.5 in either hand. These questions can range differently. Just using the curve, giving you sorts of numbers like this, like almost like you're doing the questions organically with the applet. And that's kind of the goal of these questions, to be like, if you had these applet pictures and you had created them, could you answer the questions? So you don't need to use the applet. You don't need to use the calculator. We give you the curves, and then we kind of expect you to use it. And if you notice here, this is 12.5 and this is 12.5, which makes this the 87.5th percentile. And so I'm going to write it here in the chat. that 100 minus 12.5 equals 87.5. And so this is the 87.5th percentile, and this is the 12.5th. This doesn't look to help us, but wait, there's more. This curve right here has 25% shaded. Now 25 and 75 have an interesting relationship. They're what we call complements. And you can just kind of think, wait, 25 and 75 add to 100. Now, don't you wish that this curve was just flipped to the other side? It was just flipped in reverse. Because if you were to flip that curve in reverse, then this 25% would be on the top portion. Does that make sense to everybody? That if you flip this, we'd actually have a line at where the top 25% would be. And the top 25% is where the 75th percentile is. Does that, I hope that makes sense. Ask questions if you got it. But all of a sudden we see it now, wait, 25%, 75%. If I could just flip that curve. Well, the good news is due to the laws of symmetry, we have this curve flipped and we can do it. And we see right down here that all we'd say is, well, how far below is this line? And that's what we're doing right here. We're just solving the math. 150 and 143.2. And I just want you to think about 150 and 143. Just pretend these are the numbers. What is 150 minus 143? That would be 7. So what we see here is that 7 is how far this is below. So how far is this above? 7. And if you carry the decimals, and I know I rounded it because that's basically 7, and that's basically 7 above, we're then just taking this distance it is below, which is basically 7, and then adding basically 7 to it. To get the exact number, you would take the exact difference from 150 to 143.258, and that gives you 6.742, and then you would just add that back on. And all you're doing is just flipping the curve. You're just saying, well, if it's this much below, it'll be this much above. And does that make more sense to everybody right here? I could ask you another question from this and kind of come up with something right here. If people are still wondering about this, I'll go back to it with the 5-second delay, and with people having to type responses, it can take a moment. What if I were to ask you, where is the 37.5th percentile? Where on this curve, and use this information right here to find the 37.5th percentile. So what would be the answer to that? For those looking at the screen right now, you might have to zoom in. I'm trying to think if the numbers are clear enough on your screen. Can you read the number on the outside, inside, between all that stuff? Where is the 37.5th percentile on this curve? I don't know if anyone knows the answer right here. I hope I can kind of see it on the screen. I don't know how blurry it is for you guys. Let me full screen it on mine. Little hard to read. I can read it though. Can I up the quality? Auto 480. That's as high as it goes. The 37.5th percentile is actually this number right here. And if you notice here, because if 75, yep. Well, wait. I see how he's saying. So I think Evan, you might have it. And let's see here. Good job, everybody. Love the answers, because what we have here for the 37.5th percentile. But think about this for a moment. The 37.5th percentile has to be below the 50th percentile. Here's where the 50th percentile is. You want to be in the upper percentiles. But the 37.5th percentile is going to be below it. And how do I know that this is the 37.5th percentile? How much of the curve is shaded in right now on this graphic? How much of the curve is shaded in on this graphic right here on this one? 75%. And with 75% of the curve shaded in, then what's half of that? 37.5. So I'm going to write it here in the chat. 75 divided by 2 is 37.5. And so that's what would be in either side of the tails here, 37.5 and 37.5. So what percentile is this right here? What percentile is that? Can anyone for 100 points in the chat tell me what percentile that is on the normal curve? So you can use your 37.5 and kind of think about it for a moment, because there's 37.5 from here and up. So what percentile is that on the normal curve? Any guesses? Any knowledge? You are exactly right, Raul. That is 62.5, because this is the upper 37.5%. Just subtract from 100, and that would be nice job, Daniel. I swear, I thought I made Daniel mod. There's 2 Daniels. And so that would be the 62.5th percentile. And it's the same spots on this curve, because if you divide 25 and a half, you can go up 12.5 from 50 and down 12.5 from 50, or see that the outside's still 75%. What percentile is this on the curve? I think I said it earlier, so I'll say it again. It is the 12.5th percentile, and this is the 87.5th percentile. Tom Brady, which one are you wondering about, Tom Brady? How I got, like, over here. If 25% is shaded in on this curve, then 75 is remaining on the outside. So if both of these are 75 together, because this is 25, thus both of these are 75 total, then we would cut it in half and get 37.5, as this is 37.5 and this is 37.5. So when I add up to this point, I've added up 37.5. And then I can add 25 to that and get 62.5. And then when I add the remaining 37.5, I get 100% of the curve. Does that make more sense now? I hope it does. Fingers crossed. If you have a deeper question, feel free to ask. Great job. Always be like, yeah, anytime. I'm always wanting you guys to understand it. I know this normal curve stuff gets pretty confusing. We got some Z-score stuff right here, so let's look at these Z-scores. I think you guys are pretty comfortable with this. Just remember that a Z-score is how many standard deviations something is above or below the mean. So I can look at this answer and I can tell you that whatever we observed is 1.56 standard deviations below the mean. And you can actually backwork the question knowing that. Because if this is the standard deviation, about 1.5 of the standard deviations, just times this by 1.56 and you get about 0.5. I think that's exactly what you get. And you get negative 0.5, meaning that the observation of 2 is 0.5 below the mean. You will not need to find Q1 or Q3 on the test. You do need to know them conceptually, that they are the 25th percentile and the 75th percentile. I will not make you find them with a number line, though. I won't give you a bunch of numbers. And exactly. And it is below. I hope I said that, Ivy. I'm throwing you 50 points because maybe I didn't, so I'll pretend I didn't. But it is below the mean because the mean is 2.5. And then we can use our formula right here. We could say, well, if the mean is 2.5, observation minus mean over standard deviation. So this right here will get us the Z-score to tell us the observation of 2 is 1.56 standard deviations below the mean of 2.5. So we see here that there was an observation of 2, and that is below the mean, must be a negative Z-score. And yes, and be careful with the numbers, because it's a little confusing right here. We have a lot of 2s and 2.5s, but the mean is 2.5. The standard deviation is 0.32. Let's try a quick problem online and see if you guys can get it. Let's say somebody had a cell phone battery that lasted 1.86 years. Their cell phone battery lasts 1.86 years. What is their Z-score? This should be a pretty quick one. Find it online. So 1.86 years, Z-score this. So 1.86, Z-score that. According to this curve, what would that be? Let's see who gets it. I think I did it properly in my head because it should come out to something nice and neat. You are exactly right, Evan. Nice job, because you figured out that all you did was take observation minus mean over standard deviation, and that gave you a Z-score of -2. Nice job, everybody. How about, I'm thinking in my head, okay, let's do 3.32 years. You got a pretty good cell phone battery. Your cell phone battery lasts 3.32 years. Hopefully, I hear the answer I like. If your cell phone battery lasts 3.32 years, what is your Z-score? Cell phone battery lasts 3.32 years. What is that Z-score? So 3.32 years. Exactly. I think, Ivy, I think you got it right. Maybe those are the decimals. Are those the... Maybe I didn't carry it out perfectly in my head. I got the number Ivy got, but everyone is saying I am wrong. I think it's 2.5625. Oh, I can't do math in my head anymore. Just double check here. What would it be? I guess it's not. So with this in mind, it looks like you guys are doing properly. Make sure to take observation of 3.32 minus mean of 2.5. Divide that by 0.32, and there will be your answer. So that is it right there. I'm trying to do math in my head, and I am failing. But that was close enough to what I got that it seems like you guys are doing it properly. So good job there. 2.5625 looks to be the answer. So what percent of the batteries can be expected to last 2 years or more? Now be careful. Here's what I want us to do. I want us to think about this Z-score right here. Now, what are numbers on the empirical rule you know that are close to this? What are 2 numbers on the empirical rule you know that are very close to this? So you want to see batteries that last longer than this, but what are two numbers on the empirical rule you know that are very close to this? That would be empirical rule numbers that you know the data like above and below those numbers. Because we should know 68, 95, 99.7. What are numbers on the empirical rule you know very close to this? And this is the key to solving this question. Well, if you make this number more positive, what's the first number on the empirical rule it hits? I don't know if you know 2.5. Well, what's the idea with 68, 95, 99.7? What are those numbers? Like, what does 68 mean? That's the area inside of what? Seeing a lot of answers. The 68 is the area inside of what and what z-scores. 68 is the area inside of what and what z-scores. There we go. Side 1 and -1. How about 95? 95 is the area inside of what and what z-scores. -2 and 2. Nice job. So with these numbers, when we draw our curve right here, I'm just going to write down to it. If you notice, here's where we're at. So if we just draw it out, we would get this. And the first thing I want you to recognize is that's a lot of area. That's a good bit of area on the curve. If you were to answer this question and you were to say this is like 50% or 20%, it's like, I think it's more area than that. But let's see this. Knowing 68 right here, I want us to think for a moment. If 68's between here, then we do our inside-outside trick. 68 between, 32 outside, 16 in either of my hands. I got to go a little further back or something. 68, 32, 16 in either of my hands. So what is the area above -1? What is the area above -1? So if you went from -1 and you went all the way over, you would get 68 plus 16, which is 84. And there's other ways to do that too, because you could say, well, below -1 is 16, so above -1 is 84. And if you see, that's what we did right here. So you've got, okay, -1 has 16 below it, so it must have 84 above it. And you can check your work. Always good to check your work. It should add up to 100%. Next, we see that we have 95. And with this in mind, we have 95% between here and here. And then what we would do is we'd say if 2.5 is below here, then 97.5% is above there. And this is the key to it right here. We know that this area has to be, like if we were right here, it'd be 84. And if we're over here, it's 97.5. So this area has to be between 84 and 97.5. The biggest thing, and you see me do this in class a lot, is I draw these lines. I figure out where I'm at. And usually I'll shade the rest of this curve. Because I'll shade all the way over from -1. If you notice, -1 is too little of an area, but -2 all the way over is too much of an area. So you're kind of boxing this area in right here. That's kind of the goal of it, is to box the area in. So this is the key to this question. Are there questions on this? I know this is one of the trickier ones. How about if we were to say the area above 1.2? I know I like to throw these things at you guys and see what we get. Let's go and let's see right here. So if we go to the area above 1.2, let's try that as a question right here. Area above 1.2. And this will be great because we can actually use these pictures for it. What is the area above 1.2? And you actually have pictures to help you out right here. What is the area above 1.2? Give me an estimate for an interval for what is the area above 1.2 z-scores. It has to be between what and what. You've got a big help. Let's see, we got some silence, but I don't want to give away the answer. I'm going to give 100 points. Who's got it? It has to be between what and what for the area above 1.2. Now think, wait, Raul, think for a moment here. That's a really big interval. But with that in mind, for the area above 1.2, draw a graphic of it real quick. Think about it. You've got the normal curve, and then you're at 1.2 and you're shading above it. It's not a big area. So always, every time you give your answer, draw some graphics. Because where we're on the curve is we're right about here, and we'd be shading from here up. So that doesn't look like 68 to 100%. The area above 1.2 on the normal curve. Oh, let's see. That's a good shot, Evan. I'm going to throw a big 200-pointer out here for whoever gets it. And I'll explain the answer in a moment. James, you're getting closer. James, you're getting closer. So wait, slow down. Grab a sheet of paper right now. If you have a sheet of paper near you, and especially if you're watching this review, pause it, and try to tell me the area above a z-score of 1.2. These graphics right here are a great way to figure out the answer. I'm going to give us another minute or two because this is a really good question to ponder on for a moment, because I do like asking questions like this on the test to be like, what is the area above this z-score given interval? It shows you really understand the empirical rule. And so a lot of people ask, how would you do this on the test? This is how I do it on the test. Raul, you are correct. It is less than 100. It's not greater than 68 though. Macy, nice job. Macy, I'm throwing you 300 points. Great job, Macy. And thank you for everyone for taking a shot at it. I'm throwing 50 points for those people taking a shot. I really appreciate the thinking process. Just getting your mind going on it. So let's see how Macy found that answer. Now, what Macy knows is the area above 1. Oh, I see it. Nice job, Evan. Area above 1 is 16. The area above 2 is 2.5. So when you draw your graphic, what you would see here is you're right here at 1.2. So at 1.2, if you shade from here over, you will have less area from here because you're shading, like I just put a line right here, that's less than 16%. But when I put the line here at 1.2, well, that's more than 2.5. So you just have to use your tricks. Make sure to shade it. Draw on your curve as I do in class. Draw the area above 1.2 and be like, okay, how can I use the normal curve to break this down? And I know it sounds crazy, but the normal curve is such an important topic throughout all of statistics. It's the Gaussian curve, so very important to understand how these percentages relate and the probabilities. We'll use them for p-values later on. Does everyone understand where this comes from? We're looking at this graphic because if we're at 1.2, that's less than 16% because above 1 is 16% and above 2 is 2.5. Thus, right here, there's more than 2.5, but less than 16. And I think Evan sees it. Raul, does that make sense now? And James, how are you guys doing? And ask questions if you have it. Let's throw one more your guys' way. And these curves can be used. This one's a good one right here. A little tricky, but we can still use this curve. Let's do the area above a z-score of 0.4. Let's do the area above 0.4. And definitely expect questions like this. I'm literally, sure, we'll do that one. I meant different, I meant negative, but so draw your graphic and see if you get the answer right here with the area. I can promise you there's something on the test a little bit like this, trying to give away some big hints right now. So the area above 0.4, who's going to be the first one to 200 points right here? Grab some big money points. We won't be giving out points tomorrow, so good time to get points. Who can tell me the area above 0.4? It's contained between an interval. It's between this and this amount. Who can tell me that? We'll wait another 30 seconds or so. We'll see what guesses we get. Remember, I don't mind guesses. If you're wrong, it's all right. It's too small, Nicholas. Very close. The lazy longboarder, very close. James, people are getting very close. But I want us to think for a moment. You guys are doing very well. Yeah, I'm trying to think how you got. I see you got those. I don't know how we got 64. So wait, think where we're at on the curve. Oh, Alexis. Nice job, Alexis. Hey, great job. Alexis got it right another... I think, did she get it last time? I think maybe. No, it was Macy last time. There we go. Great job, Alexis. And great job, everyone taking a guess. 50 points for the guesses and 300 to Alexis. Let's take a look at what we have right here. If we are at 0.4, we're right here. Well, the first two numbers we hit are these numbers. Agreed? Does everyone see if we're at 0.4? If we went this way and we shade to the right, we would shade too much. If we go to 1... we would shade too little. So from 1 over is 16%, and how much over is there from 0? 0 is the middle of the curve, 50%. So always draw on your curve, and Peyton, you have a very good guess, Peyton. I think that's very close to the right answer. It might be in that interval. That's close. But always use the empirical rule numbers. But with this in mind, 50 and 16 are the right answers, because just go and hit the next two numbers. I think you guys are maybe getting the theme of it. Think about what I said. Go to the numbers near it. Let's do the area below negative 0.4. And you might see something right here. The area below negative 0.4. We're just going to hammer this one down. I want you guys to get this points on the test tomorrow. I can't say I'll give away every question. So Vince, hopefully I can... so Vince, I'm going to talk this one through as people give answers. So, do you see, Vince, that negative... Nice job, Peyton. Do you see that negative 0.4 would be right here? Does that make sense, Vince? With the delay, I might just say yes or no, because they're negative 0.4 would be right here. I like it, Evan. And with negative 0.4 being right here, I know the numbers on the empirical rule are 68 for one standard deviation, 95 for 2, and 99.7 for 3. So what I do is I say, well, I know the area below -1 and I know the area below 0. So the area below -1, I'm going to use my 68 trick. I'm going to say 68% between, and thus 32 is outside, which this curve is showing, and 16 would be in either hand. Exactly, Saeed. Nice job. So with 16 below -1, because if I were to shade from here down, imagine I were to take this curve and shade from here down, I would shade more than this white region, because I'm shading from here, where I'm shaking my mouse, down. That would shade more than this white region. But if I were to shade from 0 over, I would shade 50%, because that's the middle of the curve. So below 0 is 50%, and below -1 is 16%. So shading from here down would shade somewhere between 16 and 50%. No, that doesn't matter on the test, Alexis. Nah, I'm good with that. I'm not going to be like, no, you, unless I said above or below, but I usually say between blank and blank. And I have had graders take off points for that, and students are like, I thought this was right, and I'll come back and give them points. So, yeah, no, I would definitely give you points for that. So, awesome. With the first one, the above. So let's go right here, Daniel. So if we're going above 0.4, go to the first two numbers you hit, 0 and 1. And now we shade above. Above 1 is 16, and above 0 is 50%. Because we're just going to go to the first two numbers we hit, and then we're going to shade above 1, and we're going to shade above 0. It's kind of the trick right there. You just go to the first two numbers you hit. Now, if I did below, you would be correct. Because if I say below that, and think of what you're doing, 50 and 16, the complements of those are 50 and 84. Sure, we'll do another one. I like when you guys ask. Let's do that. So let's do a trickier one. Okay, this is going to be a tricky one. Watch out, guys. Let's do below, and thank you, Connor and everyone. I like it when you guys ask. This is when it gets fun right here, when we're chatting. It's just a conversation. We should just do all class like this. I'll just go into my bedroom and just teach class. Like, yeah, I'm going to go teach class. Okay, so what is below 2.3? So what is below 2.3? So I'll write it in the chat here so people can see it. And thank you, everyone, for participating here. Below 2.3. Someone's just going to destroy it, I think. This one's tricky. Usually people get the second number wrong. The bigger number people usually get wrong. Ooh, careful. Ooh, you guys are going the other direction. You guys are going the other direction. But the numbers are a little... I like rolls at 2.5 to something. I like that. But do this for me. If you have a sheet of paper, graph it, draw it. Just draw out the curve. Getting close. Oh, we got some answers. But wait. Everyone's giving the compliments of what I want. It's not the nice compliments like, you look nice today. It's the compliments that are the other side of the curve. Ooh, getting some ladies longboarder, getting close. Wait. Close, but there's still some issues. But wait, is anyone catching what's going on here? Somebody graphed the curve, and this is the big... I see a lot of mistakes like this on the test. Everyone's gotten down a very wrong... Oh, wait. Kyle, 200 points. Kyle, you're on the right path. Grinder, you're getting closer. Grind never stops. Grind never stops. So, closer. But draw on a sheet of paper. I see we're getting closer. Okay. So let's think this through. You ready for this, everyone? We have 2.4 is the z-score. Let me see what it is. 2.3. Okay. If you shade in below 2.3, you're all the way over here. So we're at 2.3. Does everyone see this? If we shade below 2.3, are we shading a lot of the curve? I like that rule. If we shade below 2.3, are we shading a lot of the curve? Are we? We are. And so just think for a moment. When you give your answer, draw your picture and look at it. And say, wait, if I shade from here down, I'm shading a lot of the curve. I'm just a lot of it. Does that make sense? So these answers should not be small. Now, if you were to shade above, then that would be a smaller thing. Now, with this in mind right here, let's think. The first number we hit is 2. What is the area below 2? What is the area below 2? What is the area below 2? What's the area above 2? Ah, yes, 97.5. So the area below 2 is 97.5. The area above 2 is 2.5. Now let's go to 3. And this graphic isn't on here. Closer, James, closer. So I want to know what is the area between, let's just do it from scratch. What's the area between -3 and 3? Area between -3 and 3 is what? 99.7. What's the area outside? Good job, Raul. The area outside is 0.3. And then the area in one of my hands is 0.15. Yes. So if 0.15 is above here, what is below here? If 0.15 is above here, what is below? If 0.15 is above, what is below? I saved this hard one for last. Bingo, Raul, you are right. 97.5 to 99.85. So that is the key right there, 99.7 to 99.85. And it's easy if you have the normal curve on the screen. Type in empirical rule and kind of use it as a cheat for a moment, but be able to do it and know the numbers. Someone give me another random number in the chat and we'll use it. One more to really, he'll do one more, and then Raul has a question too. Connor, what number do you want, or what number do people want? And you can ask questions at any time you want. I'll try to, if I don't answer it, just re-ask it, and I'll try to answer it. What number do people want, and what above or below? 1.7. Let's do above 1.7. This is a pretty easy one now. We got this. This is almost, I think, a review because we did one like this earlier. And what is above 1.7? Did I say above? Did I mess it up? Raul, did I mess this up, Raul? Let's see. Yeah, I did do below. I did below, Raul. Maybe I said it wrong in the chat, but I hope I didn't say it wrong out loud. But that would be the answer to below. I'm going to type this real quick. Below 2.3 is between 97.5 and 99.85. So that is the right answers right there. Above it would be between 2.5 and 0.15. Those would be the answers right there. That it's contained in that interval. And so now we're doing below. Did I say below or above? I think I said above. Above 1.7. So who can do above 1.7? That's the latest one we're doing right here. I hope I didn't reverse it in the chat. Because maybe I did reverse it when I was saying it. I'm kind of thinking the answers as I come up with them and stuff like that. So whatever I say in the chat is golden. That's the one we're using. So above 1.7 is what? And I will probably do regression next, or I think Ivy wanted some mosaic stuff. So, well, if we were to take a z-score of 1.7, what would be the area above 1.7? And Nicholas, nice job. Nicholas, notice that the first two numbers you hit are 1 and 2. So the area above 1 is 16, and the area above 2 is 2.5. And I kind of chose this one because it goes full circle back. We kind of looped back to where the graphics really help us here. And if you notice, we got very similar stuff right here because 16 and 2.5 are actually the complements of 84 and 97.5, which you notice how this is between -2 and -1. What is the area below this? Well, the area below this would be 16 and 2.5, so the area above it is 84 to 97.5. So you get some interesting stuff like that when you use the curve. For that which question? The previous one? No, I would not. So no, that would be too big of an interval, or the not the right numbers. And if you tell me, yeah, cool. Great questions. And so, Ivy, I think you wanted mosaic plots, and we can... Do we have mosaics on here? Where's my mosaics? Here we are with a mosaic plot. And feel free to ask anything else. So the answer to that last one was 16 to 2.5. The area above 1.7 is between 16 to 2.5%. 2.5, just 2.5. So there's always more decimals if you do it. The answer is 16 to 2.5. So, yep. And then the area, Kyle, your question, the numbers you've written, Kyle, could be the area above 2.1. Let me think here. But the thing is, your last number needs to be 99.85. A lot of people make that mistake with the 99.7, because 99.7 is the area contained between -3 and 3. But remember, below 3 is 99.87. And above -3 is 99.87. Make sure it's always, people forget that last little bit. I see that mistake a lot. So that would be that right there. So does that mean if you ask for negative... We're throwing so many questions right now. The area below -1.7 would be 2.5 and 16. And I'll show that again real briefly here. The area below this number right here, which this is basically the same number. If you notice, 1.7, -1.7, and -5.6 are in the same spot. They're between -1 and -2. So the area below that would be 16 to 2.5%. And so that these graphics would help with this right here. So that's got it. Great job. Great question, Daniel. Let's see. Let's go down here and go to the mosaic plot. And we see right here we have some Icelandic dolphins. And the first thing I notice about this mosaic plot is I notice that there's a relationship. How do I know that there's a relationship in this mosaic plot? What is the key, like, oh wait, there's an association with this mosaic plot. I see it. How do I know that? How do I instantaneously know this? Let's say I really want to see those dolphins traveling. If I really wanted to see the dolphins traveling, I would go and visit them during I'd say the afternoon. What if I was like, oh man, I really want to see dolphins feeding? It's so quiet. Don't leave me hanging, everybody. If I'd really want to see them feeding, I would go during the evening. So I think, and you guys might be responding to the old questions right here. So if you notice, the activity the dolphins are doing is related to the period of day it is. And if there wasn't, let's go back to, will there be questions on the mosaic, like 15 on the best? I do not on the, are you talking about this one? We'll see that in a moment here. I don't quite understand, Ivy. Re-ask or rephrase it and I'll see if I understand. So with this right here, there is an association because the blocks don't line up. The period of the day gives us some insight into the activity they are doing. Based on the mosaic plot, approximately what % of these dolphins' mornings were spent traveling? And when you look at this right here, you'll notice that in the mornings, about 55%. And we were very lenient when we graded this. If people put 52, 53, we were nice. I mean, as long as they didn't put like 40, because obviously it's more than 50%. And you see here, in the morning, they were traveling about 50%, 55%, excuse me. But if you look over here, overall, they travel about 50%, because this is the marginal display of activity. So the marginal display of activity shows around 50% of the time they are traveling overall for everything. Based on the mosaic plot, what time of the day were they observed the least? This is actually the marginal display of period. So they were observed the least in the morning because if you look at this, this is just a bar chart kind of stacked. Oh no, there won't be leaf report. There will not be none of that. No worries. That will be on test 2. So do not do decision tree or probability. So the morning right here is where they are observed the least. And is there a relationship? Yes, there definitely is. And the heights of the bars tell us this. And there won't be decision trees or probability on this test. So do not do those topics. Do not do those. 13, part 4. Let's make sure that's one we want to do. And let's take a look. Oh, we got some regression. Nice stuff. Do you mind if I start this from the beginning right here? Let's see where the regression starts. Cool. I'm going to start this from the beginning, Tom Brady. And let's do this. I get to say Tom Brady, I'll chat. Okay, we have a regression equation right here predicting the height of these nursing students from their weight. And the first thing I would notice, and we did models like this in class, is that the intercept's going to be illogical. And can anyone, I want to see this in the chat. I'm going to have you guys write this out. I think I might go grab just a drink real quick. I'm going to grab a drink, and when I come back, I want to see in the chat interpretations of the intercepts for 100 points and interpretations of those slopes for 100 points also. Give me slope and intercept interpretations. Challenge yourself for a moment. Write it out. I'm going to grab something to cool off because I turned off my air so you guys wouldn't hear it blaring in the background. And here's the key to energy. It's Red Bull Blue. Oh, I was too quick. I was way too quick for you guys. So, get my Red Bull opened up here. Pulp a coaster. Hopefully I don't knock this over. But, I should try to get sponsored by Red Bull. It probably, exactly. So the question is, write out the interpretations of the intercept. And I've really kind of said like, hey, interpretations of intercept, interpretations of slope. Let's see, like slope. For every 1 pound increase in weight, good, height increases by 0.085 inches. I like that. And I would give you full credit for that. Peyton, I'm throwing you 200 points. Thank you, Peyton. I would, this is the way I would say it. For each 1 unit increase in somebody's weight, correct? Or nursing student's weight, I'm not going to be that specific on the test. we would expect their height to increase by 0.085 inches. And I always like to throw in the expect because that's kind of what the model's predicting, or we would predict their height increases by this, and it's the line we're talking about. But Peyton, you would get 100% credit on the test there. That is an excellent answer, and thank you so much. If a weight was 0, I like that you threw in a little expect there. Thank you, Daniel. If a weight was 0, then the height would be 54.55. Yeah, great job. We would expect the height to be, and what would you like to add to that? Does anyone want to add a little addendum as I drink some more Red Bull? So surely we have an addendum on there. That sounds a little bit weird. If somebody's weight is 0, then we would expect their height to be 54.55 on average. That sounds a little off. What do you guys think? That is definitely a case of no practical interpretation. Nice job there, Macy. No practical interpretation, a logical intercept, just doesn't make any sense. Just no sense at all. So, not good right there. So Mary was one of the nursing students, and that was part of the study. Suppose Mary weighs 110 pounds. Use this to predict Mary's height. And all you need to do is just plug in here and solve. The next one's a little bit more complicated because it says Mary is actually 65 inches tall. Now, this is her actual, and remember we talked about residual RAP. Residual equals actual minus predicted, because the residual is just how far you're off. Here's what it actually is. Here's what we predicted. Residual is how much you miss by, and we were talking about that today. So residual, which is E in notation, is actual minus predicted. And so we see here that we miss her height by 1.1. So this is actual minus predicted. And if you see, that means the line is below her because the line predicts her to be 63.9 inches tall. She's actually 5'5", 65 inches tall. And so this is how much we missed her by. I think number 4 is a tricky one. Here's our interpretations. And this one is a tricky one because let's see what they actually give us. John is another nursing student. John is 68 inches tall. Now, if you look at how tall he is Y, but it's not Y hat. Y hat is predicted Y. So we know John's actual height. It also says that the model misses him by negative 1.47. So these are the things we know. We know Y, we know the residual, and we want to find out how much he weighs. Now, we've got a little bit of work to do here. If you notice when we look at these equations right here, we can say that John's residual, which is E, is going to be his actual height minus the predicted. But go back, let's do some algebra here. The predicted is just this equation. Remember, the predicted is 54.55 plus 0.085. So all we're saying, wait, this is Y hat, and we want to find X. We're not actually interested in this Y hat because we're not saying predict his height. I think that's what we're predicting right here. We're not saying predict his height. We're saying what was his actual weight. So with this in mind, we're going to take and we're just going to drop this into the equation right here. If you notice, we know his residual. Residual equals actual minus predicted. And so when we take this right now, we take residual here, actual, and predicted is the equation. Yes, you will get a formula sheet. You will get residual equals actual minus predicted. And I'm trying to think if I put the regression equation on there, which is y hat equals b0 plus b1x. Maybe I'll make sure it's on there. But this right here is the regression equation. Y hat equals b0 plus b1x. And so all we're doing is saying, well, if this is y hat, let's plug it in. And then you algebra out and you solve. So it's a big algebra problem. It's a tricky one. Does that help you understand it better? I'm trying to remember who asked it. Basically, if you get questions like this, the biggest thing to do is label what you have. The notation's so very important. It helps you solve each one. Tom Brady, did that help? Because all you're doing is saying, I know how tall he actually is. I know his residual. I want to find X. So let's plug in the residual here. Let's plug in how tall he actually is. And then let's just solve for X because we want to find his height. And the height is X. So height is in this formula right here. And we drop it in. I think it looks like people are getting it. It's very much an algebra problem and a notation problem. That's all it is figuring out what notation you have and what you can solve for. So definitely anytime you see a number, really great way to do word problems. Anytime you see a number, circle it. I know it sounds crazy. They're like, I can juggle all these things in my head. I tell myself that all the time. And you guys see me in class. I'm like, oh, let me think it through. But when you get a problem, sit down and start circling those numbers and take notation. Like this right here, he is 68 inches tall. I would circle this and I would write Y immediately. We calculated his residual. I would circle this and I would write E right here. And then when you get to your formula page, you'll be like, oh, wait, I have E, I have Y. I don't have Y hat, but wait, Y hat is this formula, and I want to find X. So just drop that in right here. If you notice, it is still just E equals Y minus Y hat. Usually 2 decimals, unless it's like a decimal itself, then 4. But I'm forgiving as long as you don't do something crazy. I'm a nice grader. No one's ever complained and been like, you counted off because I rounded weird. Just carry significant digits till the end. Usually, that's my saying. Always carry them as far as you can. But if the answer is like 18.21 and you put 18.24 and I look at it and you're like, oh, you did it right. Yeah. It is used for predictive models. You're very right. This is a predictive model. We are predicting people's heights. So Y is the actual and Y hat is the predicted. So you do have Y's in predictive models. There are actuals. Like what is someone's actual height is the Y, where someone's predicted height, which you just put a little hat on this, would be Y hat. So Y's are used in predictive models. We need to know what someone actually is if we're looking at the prediction. We'll compare the prediction to the actual. Well, doesn't the question say it used the prediction model to get his height in the question? Mm-hmm. Well, so we're actually using the prediction model to get his weight. So clarification right there, we're actually asking what is his X, right? Or excuse me, his X is right here in pounds because we're finding his X because Y hat is this right here, which uses his weight to make the prediction. So his X is what we're solving for. It's a little confusing because height and weight sound so similar, but we're saying his residual is equal to his actual height minus the predicted formula for height. And in that predicted formula, we need weight. And then we solve for weight. It's a little confusing. This was a tricky one on the test. Definitely caught a lot of people. But we're solving for the X in this problem right here. I've done this too. When we did this test and I had to work in stat lab, I made a mistake. I flipped them around and the student's like, and I'm just like, I got it mixed up. It's the height and weight makes it tricky. I think just the words being so similar. I've definitely. Let's look at this regression one right here. I love regression. Okay, what's our conditions on regression? You guys know I love this question. Always drop these major hints and we're losing people. Keep going for another 20, 30 minutes. What are the conditions on the regression right here? You guys should know them instantaneously. Should be like, boom! I know those conditions. No one knows the conditions? 200 points for my conditions. I didn't make you guys yell them loud enough. I should always yell these conditions. I should be hearing somebody yelling them out right now across the street. I hear one condition. Boom, Kyle, 200 points right there. But don't forget, and Ivy, nice job throwing it on at the end. Well, why are there, and people ask this sometimes, there are 3 conditions. I almost feel like I'm preparing for the semester. During the semester, I don't know exactly what's on the test, and I don't teach to the test now. But during the semester, there's curveballs and there's stuff on the test. I'm like, oh, I didn't teach him it this specific way with these specific words. Which, you know, in the real world, you're going to hear things differently, so it's all right. But when it comes to the test in the summer, I teach my class. I control the test, so I can control exactly how I ask you guys stuff. So it's a little bit better in that sense. So I know what's on the test 100%. But during the semester, sometimes we ask a question, and I'm trying to think if this is on the test tomorrow, but I want to make this clear. The 3 conditions are for what? There are 3 conditions for what kind of thing that we're doing. If we do what, there are 3 conditions. We have QQ straight enough, no outliers. Those are the conditions for. First time we learned them, they were for. What are these conditions for? What do they mean? What am I looking at here? Close. These do apply to linear regression. We better add in, does the plot thicken for linear regression? And linear regressions require scatter plots, but the first time we learned them, it was for correlation. We learned these conditions for correlation to see if correlation was a good idea. And correlation looks to be a decent idea here. But when we have regression, the 4th condition for regression, to make regression appropriate, heard someone yelling outside. Thought it might have been a QQ straight enough, no outliers. The 4th regression condition for regression is, does the plot thicken? Or the plot does not thicken. We don't want the plot to thicken. We know plot thickening bad. And I really don't see plot thickening here. So QQ straight enough, no outliers, plot doesn't thicken for regression. QQ straight enough, no outliers for correlation. And correlation regression, they use the same plot. They're kind of the same thing, very similar. One gives you R, one gives you R squared. They're very similar, so they have very similar conditions. And we've tripped people up when we say, what are the 3 conditions for correlation? And they're like, wait, I thought there's 4. And it's like, no, there's a 4th condition for regression. And then sometimes, yes, correlation has no plot thickening. No, correlation does not have plot thickening. That is not a condition for correlation. Correlation is only QQ straight enough, no outliers. So good question right there. Then regression is QQ straight enough, no outliers, plot does not thicken. So you check the residual plot in regression, which is still get plot thickening. Do you guys think which gives you R and which gives you R squared? Correlation is R. That is literally what correlation is. And R squared is percent of variation explained, which is regression. R squared is percent of variation explained, which is regression. You know, I really like these YouTube reviews. Maybe we'll start broadcasting more on here. Like maybe I'll start doing, maybe even during the semester we'll do like stuff if you guys think is good. Which is more useful? An application question. Well, since one is an aggregate of the other, correlation can tell you the direction. Strength, direction, form, unusual features is correlation. The 4 things correlation tells you. Well, I mean, we want it to be linear or else we're not doing linear correlation. And strength is denoted by how close it is to -1 or 1. 0 is the weakest correlation. Direction is denoted by the positive or negative sign, or if it's 0, it doesn't go in any direction. And unusual features will actually hurt the correlation. So usually an unusual feature causes an outlier issue, which makes the correlation not appropriate. R squared. I do not know if there is a game that just happened or what, but there's yelling in the fort as usual. Can you say again what R tells you? Strength, direction, form, and unusual features. That's what R tells you. Strength, direction, form, unusual features. Strength is how close it is to -1 or +1. 0 is the weakest. The other ones are the strongest. Direction is told to you by the positive or negative, where close to 0 is neither. And strength, direction, form. Form is either linear or not linear, and in this class we'll focus on linear. And unusual features would be things like outliers. And I wouldn't call this an unusual feature right here. It's just a little further away. I would also not say, and now we're talking about regression, which is plot thickening. I don't really think this has plot thickening. I think some people answered it does. I don't think we said it has plot thickening. It's usually look for good amounts of evidence, and we usually try to make it very clear. This looks to be a decent scatter plot. Don't be like, that's an outlier, that's an outlier. I'll try to make it very clear when there's an outlier, and don't be like, there's plot thickening. It's like, look for a good bow tie or something that kind of spoons in or goes out like that. So I don't think we have much of an issue here. Let's see here. We might do the we probably won't do interpretations because we've already done it. So here, another chance, get those interpretations. I want you guys to go ahead and try to interpret this regression right here. Interpret the slope, interpret the intercept. First person to get them gets 500 points. I really want you guys to know you need to be able to interpret these and pretty quickly. The interpretation for the intercept is when x is equal to 0, y is equal to b0. When x is equal to 0, y is equal to b0. The interpretation for the slope is for each 1 unit increase in x, we expect y to increase or decrease, depending on what it is, by b1. Kind of close. Let me see here. An arm length of 0 is heads. Be careful, because you're saying, and think about what you're saying too. And so first of all, let's break it down. When somebody has an arm length of 0, we expect their head circumference to be 46. And that's, so we don't want to say it is this when it is this. It sounds a little certainty. We don't want to say things are certainly this. It's just saying this model would predict that when somebody has an arm length of 0, we would expect the head circumference to be 46.7. So does that make sense? And it does not sound practical. We talked about this before. That's not a practically significant or a practical intercept. It has no practical interpretation. Because we do know that the shorter your arm, the smaller your head, the longer your arm, the larger your head. So let me write it out here for you guys. I need to move my drink so I don't knock anything over. And the answer would be when arm length is equal to 0, we would expect someone's head, I just hit the Control Z. Head circumference to be 46.78, And you could put on average at the end of that. I think expect kind of deals with that. And I think we have the answer to the next one. When arm length is equal to 0, we would expect someone's head for circumference to be 46.7 inches on average, or centimeters. These are in centimeters. But I'm not super critical. And I think we have the slope. If arm length increases by 1 centimeter, then head circumference increases by 40... Is that what it is? Wait, I see a 46. Not the 46, though. Just the 0.14. So very close. Good job, Saeed. And very close. I'm going to take Saeed's and just make a little correction right here. Pretty much exactly. Let's put this in. I'm going to round this to 2 digits. And it should be this right here, because this is B1. We expect every centimeter of arm length, head... So for each additional increase in arm length, increase, I'll write the whole thing out again. For each additional centimeter increase in arm length, we would expect someone's head circumference to increase by 0.14 centimeters. There we go. So we have this right here. And I wrote out the intercept. It should be, that is the intercept above, and here is the slope right here. For each additional centimeter increase in arm length, we would expect someone's head circumference to increase by 0.14 centimeters. So remember, increase, decrease is denoted by the slope. So this is the slope right here. Has everyone got that down right there? Pretty good stuff. This is... Actually, this correlation right here is kind of weak. That's a good question. Grind never stops. Great job. You already found the correlation, which I was literally going to ask as the next question. If you square root 0.11, you get 0.33, which is the correlation coefficient. That's moderate. Moderate weak, I'd say. And I won't quiz you on like what is moderate weak. You could just tell me correlation is 0.33, and that's kind of weak. It's a kind of weak correlation, or moderate weak, but I won't... If you tell me it's 0.33, you're fine. But why is it not negative 0.33? Well, because when you square root something, it could be negative or positive. So why is this not negative 0.33? Because when you square root this, it could be negative or positive. I don't know. So, Raul, that is the next question. You got it. So why is it not negative? Simple answer. There's a misconception. Yeah, we're going to do that next, Raul, I think. Yeah, if you square root the number, well, but I mean, it could be positive or negative when you square root something. And why are we only taking the positive number, though? It could be negative. How do you know it's positive? Pretty easy answer right here. I've thrown this trick on the test before many a times. Can't give away all my tricks. It's not the length. The correlation tells us... 2 people said you can't have negative length. I'm wondering... The line. Yeah, the line. Yeah, Kyle, you're right. Yes. So the correlation... so to clarify, ask questions if you have them. Great job, everyone answering. Love it. The correlation is going to tell us that it's positive and the line goes up. And if this line goes down, it's negative. Exactly. In the house problem, you can have multiple square roots, but the square root of a number is positive. But in this instance, it is positive in this instance. But if the line were to go down, then you'd use the negative root. You'd use the negative root of the square root. So it'd be that right there. So correct. Yeah. And how do you know which one it is? You know it is positive because the line goes up. Exactly. And that's how we decide here that it has to be positive. But a lot of times on the test, I'll make it negative to trick people. But that's good stuff right there. And Raul, you brought up a very important question right here. You said, what about the r squared? And sorry with the 5 seconds delay, I think you get it. And I'm like, yes, got it, yes. With the r squared, how do we interpret the r squared? I want to see you guys write that interpretation. This one should be a quick one because you're just like, boom, boom, boom. Like when you look at this, you just go, this, 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 and you're done. Who can do the r squared? Type it in that chat. Give it a shot because you're going to be writing things like this out tomorrow. R squared is probably one of the most important topics we'll cover. We'll come back to it again at the end. But R squared is a very important topic. in the world is r squared? How do we interpret r squared? Give it a shot. Let's see it in the chat. I like it. 11.59% of heads. Careful, you're really close. Throw in the variation. The variation means the up and down. You're right. That's basically it. Just throw in variation. 11.59% of the variation in head circumference can be explained by the variation in arm length. And variance works too, because variance is variation. And don't say done, because done almost sounds like that it's doing this. It is controlling this. It's kind of cause and effect-y. It's just that it explains it. Like you can say something like 40% of our ice cream sales are explained by shark attacks. And if you say 40% of our ice cream, 40% of the variation in our ice cream sales is done by the variation in shark attacks, it kind of makes sense, but it does sound like the shark attacks are doing it. But 11.597% of the variation in head circumference is explained by the variation in arm length. Boom, right there. And arm length is doing the explaining because it is the X. So nice job, everybody. Good stuff. Let's continue on. How do we know, and I think this was brought up in class today, how do we know that this is statistically significant? We look at the slope of the line, and here is the slope variable, and here is the significance. That slope is statistically significant. So the slope is statistically significant, which means it's not happening by chance. And yeah, I think, does everyone understand that? It's below 0.05 exactly, which that literally means anytime you see below 0.05, statistical significance. Why do we not care about this intercept value? Because that's the intercept p-value. So the intercept p-value is the intercept significant? And the intercept is just the point at when the line hits 0. So that really doesn't matter. We care about the XY relationship. We care about the slope of the line. So this, and it's unlikely by chance. We'd say it's unlikely by chance. So this is unlikely by chance. So this relationship we see right here, that looks moderate weak, is unlikely by random chance, which means looks like there's a relationship that's not happening by chance. So that's got it. Let's do a few more questions here. We're not going to do decision trees because we didn't cover that. But what questions are there for those who've been looking at the practice test or the other practice test? What questions are there on which ones? So you can be like, go do this one, Brian, and I will do it. I will answer that question and explain it in greater detail. I think this goes back to the very start of the class, and if people have questions, they can bring them up while I'm talking about this. But when we look at this right here, we've got relationships with variables. And we see here that we have somebody's, let's do the true-false, sure, we'll do that next. And we have somebody's transaction number. Tell me why a transaction number is an identifier. Why it is an identifier. How do you know something's an identifier? This kills me. It's just like an identifier can never what? It never repeats, exactly. When people go and buy from this gas station, they'll never have the same transaction number. Because you can't be like, oh, let's look at transaction number 9211. It's unique. And it doesn't have to be a number. It just has to be something unique. And this one is a unique number. So, Evan, you're exactly right. This one is a unique number, and it will always be unique. You could have a A9853, maybe that's store A, and B9853, that's store B, like transaction 9853 at store B. And so sometimes they have letters. But they're always something unique. You could, especially, what was our identifiers in the Kahoot? What was our identifiers in the Kahoot? What was the identifiers in the Kahoot? Did we have it? The usernames, exactly, because those will not repeat. Kahoot won't let you use the same name. So that's your identifier. It can't repeat. And that's why you can't be like, everyone's Brian. It won't work. The type of gas is categorical. Number of gallons, because it's, types, it's what category. Number of gallons is quantitative. How many gallons of gas did you buy? Did you pay at the pump is a yes, no. Did you buy food inside? Yes, no. And we get into, this is a little bit of an easy one, but watch out because this could be store number. Now, if this was store number, like let's pretend this didn't say number of gallons and it just said store number, what would that be? I like that. If this said store number, What would that be? Imagine these is like store number 22, store number 26. It would be categorical, because you wouldn't say to somebody, how many store, it doesn't make sense. You would say to someone, what store did you go to? And store number 22 is a category of stores. And then that could repeat in the data set, so it wouldn't be an identifier. Yes, the test is pretty similar to the practice test. It's so funny. We've been making tests the same way for years. It's been like a lot of the same people, Jamie Paul, Missy Morris, myself, and Charlie Quick, and a lot of Terry Higgins now, and Alan Panel coming on soon. We've been making the test for years, and sometimes students will come up and be like, oh, the test was so easy, it was just like the practice test. And then a student will come up like later that day, be like, oh, that test was so impossible, it was nothing like the practice test. So I hope you guys feel it's like the practice test. I feel like we do make the same tests a lot, but yeah. For the last 10 minutes, anyone want to more than normal curve? We'll go back. I'll do a review of that in a second roll. The normal model can be used for all distributions. Can it? What if the data is really skewed? No. When do we use the normal curve? What measures does the normal curve have to talk about it? What measures does the normal curve use to talk about the data? It measures the what and what for the curve. It's always a fun time in chat. The normal curve measures what and what, or it looks at what and what to talk about the data. The normal curve looks at the mean and standard deviation. So the mean and the standard deviation, sometimes in these reviews, I have like 200 people, so the answers sometimes fly up a lot quicker. So when the curve, when exactly as Grind says, when it's pretty normal looking, we'll use the mean and standard deviation, and when it's not normal, we'll use the median and IQR. There's some review material right there. Median and IQR is for skewed data, where mean and standard deviation are for normal data. An observation with a z-score of 0.5 would be considered an outlier? No. And I like to say that things more than 2 or 3 standard deviations are away. And 3 is like an extreme outlier. 2 is a minor outlier. So you won't see me giving you in between things. I won't give you like 1.9 or 2.2. I'll be like 4. Is 4 an outlier? Definitely. Is 1 an outlier? No way. And I think I maybe talked about this in class. It's like if you had a friend who's a guy and he's like, I'm 6 feet tall. I am so tall. And you're like, well, you're above average, but you're like 1 standard deviation above average, which is taller than most people. But you wouldn't be an outlier. But if your friend had a z-score of 4, then they would have a height of 6'9", and they are definitely an outlier. Then they are extremely tall, because I was using a model there where 5'9" is the mean, which is what used in class, and the standard deviation is 3. 3 standard deviations is a foot, so you're a foot taller than 5'9", you are 6'9", right there. Normally distributed with a mean of 5'9" and a standard deviation of 3 makes somebody with a z-score of 3 6'9", which is extremely tall. And so yeah, if all the data is right skewed and you convert them to z-scores, then these will be z-scores. They'll be normally distributed. No, changing things to z-scores doesn't change the shape of the data. It puts it in context of a mean and standard deviation. So you're just kind of changing the context of the data to z-scores, and that won't change the shape of it, or else you could make anything normal. We, funny enough, have ways to do that, but that's not how we do it here. Good stuff here. I'm going to go elaborate on this one. Bar charts are used to graphically display both quantitative and categorical variables. No, bar charts are only used for what kind of data? And let's then elaborate on that kind of data and label off a bunch of graphics that are used for that kind of data. Bar charts are only used for what kind of data? And then start telling me graphics that are also used for that kind of data. So if you already know what bar charts are used for, what data are bar charts used for? And then also, what other graphics? Ooh, careful, careful. Bar charts. Oh, I see a lot of quantitative here. So it's not quantitative. It's not quantitative. JK, just messing with you, bro. Bar charts are used for categorical because bars go with your pie. You could make a bar chart of your favorite pies and a pie chart of your favorite bars. That always sticks out in my mind. Try to connect it for you guys. I see Grind says histograms are for quantitative. Very correct. So let's elaborate on categorical here for a moment, and we'll do quantitative next. So elaborating on categorical, what other displays do we have for categorical data? Bar charts are definitely for categorical. What other displays do we have? What other displays do we have? Yeah, histogram. And histograms are for quantitative, so only do categorical right now. Pie is for categorical. Pie charts and bar charts go together. Those have to be. So think about what would I make a pie chart of. I make a pie chart of the bars I go to. So there you go. It's How I Met Your Mother joke. And then I make a bar chart of my favorite pies. So pies and bars go together. Other things, we saw one earlier. It was bivariate categorical. We saw a bivariate categorical earlier. Any other? Surely a few more. We got that weird one where you put the bars in order. Pareto. Ivy's right with Pareto. That's the bars in order. Mosaic is the bivariate. And then you got other stuff like pivots can be used. I mean, that's general all-purpose. Contingency tables are not graphical, but those give you the counts. Scatterplot is for bivariate quantitative. So now that we've done categorical, which is bar, pie, Pareto, mosaic, and then frequency table, contingency table are the numbers. Those aren't really displays. But now that we've done categorical, let's do quantitative. What are the quantitative displays that we have? So I've seen scatterplot and histogram. We're running out now. We've only got a few more. Scatterplot and histogram, surely one or two more. It's always How I Met Your Mother jokes. I missed that show, but I don't miss the last season of it. We've got box plots, scatter plots, and histograms. I like it. And stem and leaf. Nice job. Yes, stem and leaf. I actually was forgetting that one for a moment. I would have been like, what's left? Stem and leaf. You're right. I think that's basically it. Scatter plots are the bivariate. You can do side-by-side box plots, but side-by-side box plots would actually be a categorical quantitative display. You're still displaying a quantitative variable with the box plots. I'm trying to think if we have side-by-side box plots on here, and here they are. If you notice, gender is categorical, but how long were you in the shower for is quantitative. So the box plot itself, a box plot, is quantitative, but side-by-side box plots give you categories like a box plot for this group, a box plot for this group, but it's still quantitative. Box plots are quantitative. You're just looking at multiple box plots for each category. Going down further, let's see right here. Every time an X variable is added, no, not doing that one. When doing a pivot chart in Excel, the default value displayed is the sum. You know, look at that question. I don't love it. It's kind of like, did you make a pivot chart? Do you know? Which I always have a hard time writing those questions. And the answer is that is very true. That's why every time you made your pivot chart, you had to change it over to average. So I don't love that question. I wonder if I wrote it. I probably wrote it. And if you go outside the X range, you are definitely extrapolating. And there's been some requests to go back and do a few more of the what is the area above. And so we kind of got our graphics up here. And definitely want to point this out. There are other practice tests on here. There's the Quizlets, whatever you feel best reviewing. And I'll try to update this soon after this test. Extrapolation. Extrapolation is when you, and I'll go back and I'll mention that here. So use the options available for you. And we'll go to an extrapolation right here. And I'll make up an example of an extrapolation. Okay, hours practice. Oh, cool. This one might have actually had an extrapolation in the model. So this is how many points the team is scoring in a game. And so the coach realizes this. The coach is like, wow, you know, we definitely see a linear relationship between how many hours a week our team practices and how much our team scores. And he's been tracking this data. He's like, except for this outlier here, because we've got the QQ straight enough. No outliers, that's an issue. This would not be plot thickening. That's more of an outlier issue. If we're doing regression, which I think we're just doing correlation right here, but this is the fourth condition. If you notice QQ, straight enough, no outliers. There's no plot thickening because this is not regression. We're not doing regression yet. But this would probably not be a plot thickening issue. It's really just an outlier. It's just something that breaks the trend. The data doesn't look to be getting thicker or thinner at any point. So with this right here, the coach sees this relationship, and this is how I'd write the test question. The coach realizes that the more his team practices, the better they do. No duh. He decides to have them practice 20 hours a day leading up to the game, 5 days a week, for the Saturday game. So Monday to Friday, they practice 20 hours a day, only sleeping 4 hours, for the Saturday game. Maybe he lets them sleep a little bit before that. 20 hours a day. And I'm going to, real practice here, real practice, really bringing it in. And so explain what is the problem of him using his model to make a prediction for 100 hours. Because 20 hours a day would be 100 hours. He's way off. He's way over here. He's saying, oh man, we're going to score we're going to set some high school records. What's the problem with using the model to make predictions then? What is the problem with using the model to make predictions? That is definitely an extrapolation. Why would the 45 points scored for 43 not be This one right here is not an outlier because it follows the bivariate trend. Now, it is unusual in the univariate senses. This is a lot of hours practiced. This is a lot of points scored, but it follows the bivariate trend. Something that is an outlier in a scatter plot does not follow the bivariate trend. It was not unusual for them to score 20 points, but that's an unusual amount of points for how many hours they practiced. An outlier in a scatter plot does not follow the bivariate trend. This point does not follow the bivariate trend, where this point right here does follow the bivariate trend. So the more, and we'll go back to the other scatter plot just to see it, the further away things are, like there's your biggest outlier right here because the trend is going through there. So, and that's not really a big outlier. I wouldn't call that an outlier, but it's the one that goes against the bivariate trend the most. If you go to this, this right here is more of an outlier. That is, and that is. These ones closer to the line are less of outliers. The more it follows the bivariate trend. Thank you, Raul. I think Raul answered. And then the extrapolation, which I was talking about right here. Extrapolation is when you leave the x-axis to x-axis. Hard to say that. Extrapolating is going outside the x-axis of the model. So you would go outside of here to here, and that's extrapolation. Extrapolation. You're extrapolating. So that is extrapolation. That has that. Does that make sense on what extrapolation is? It's the coach actually doesn't really know or understand what happens if his team, he might assume if they don't practice they might score like 4 points or actually get two safeties. That'd be a very weird game. I think it's safeties too. There's my football knowledge complete. I should wear my sports shirt. But someone confirm a safety is 2 points or 2-point conversion is 2 points. But we don't really know what happens with less than 10 hours of practice. We don't really know what happens with beyond 44 hours of practice. Extrapolation is when you use x's that are outside the x bound of your model. That's extrapolation, making predictions with x's that are outside the bounds of your model. Does that make sense to those wondering extrapolation? And am I correct that a safety is 2 points? It's one of our lesser concerns today. What's interpolation? Well, we've talked about interpolation in this class. I'll double check it. I swear I've heard that word. It won't be on your test. I'll promise you that. I know what interpretation is, and we use that a lot. But I don't think we'll be doing interpolation. I feel like I should know what that word is, but it's escaping me at the moment. I'll probably look it up afterwards, and feel free to send me an email, and I'll talk to you more about interpolation. We've got the normal curve stuff right here. And let's go back to our graphic right here. Let's go to the other graphics right here. Okay, we're going to do one last one here, and then I'll take any last questions. Getting close to 7 here. Hope you guys enjoyed the review. We got like a third of the class in right now. Good stuff. So let's see the area above. We'll do 2 more. I'll make this one easy. The area above a z-score of negative 3.5. Above negative 3.5. And graph it. Grab a sheet of paper and graph it, please. Grab a sheet of paper and graph it, please. Because if you give me an answer, I want you to be like, close-ish, close, close. It's definitely not all the curve. I mean, it's almost all of it. You're right. Is your name The Grind Never Stops? Is it like an MMORPG name? Like grinding in a video game, like to get levels? Is that what that is origin of? Peyton, you're very close too. Peyton, you're very close. Let's see if people get some answers here. Kyle, you're part of the answers. We've got enough to build the answer now. And you guys are coming up with some pretty good answers that would definitely... So I want an interval. I want an interval. It's more than this, but less than this. And we actually have all the numbers we need. So when you draw on your sheet of paper, you're going to be all the way down here. What is the first number you hit if you go up from negative 3.5? If you go up from... Good job seeing you, Evan. Good luck tomorrow. Oh, man. Oh, dude. Don't. World Warcraft's bad. Don't do that. We hit negative 3. I mean, it's all right, game, but just, it'll pull you in. So negative 3 is the first number you hit. Now be careful. What percent of area? Let's do it this way. What percent of area is below negative 3? What is below negative 3? What is below negative 3? I know I'm saying above here, but what is below negative 3? Below negative 3 is 0.15. Is that Correct. 0.15. So what's above -3? Because 99.7 is here. 0.3. 0.15 is below. What is above? If 0.15 is below, what's above? 99.85. Now here's the thing where it gets confusing. We don't have any number below -3. So what number should we put if we don't know another number? Well, it's got to be between 99.85 and what? We saw those numbers earlier. 99.85 to what percent? This is basically all the curve. Exactly. So the answer to this one was 99.85 to 100%. So nice job. And we'll do a bit of a more concise one here. You guys pick a number, any number you want. Don't make it too crazy. I mean, if you do like 5, I'm like, well, above 5 is basically the whole curve, and below 5 is basically nothing. But what is another number on the curve? 2.1. Above or below, Raul? Above or below 2.1? Above 2.1. Who can get it first? I'm going to throw 1,000 points to the person who gets the last question. Then I'll take all you guys' individual questions for a little bit longer here. What is the area above 2.1? I think I have it in my head. Be careful. Draw it on your sheet of paper here. Raul, you're on the right track, but I want you to draw it. Wait. Oh, you're right. Raul, you're right. I was like, you're doing so well, and you are right. You see, sometimes I get them wrong. I drew it in my head. I'm pretty sure that's right. Let me think. What I did, I thought your answer was negative. I don't want to say out loud what I was thinking. I'll say it. I thought it was negative 2.1. So I had in my head 97.5 and 99.85. Just ignore the yeah. Well, you can draw these out on your own for the test. Like, draw your own. So you got it right. I flipped it in my head. I was thinking above negative 2.1. So I did it the wrong side. So excellent job right there, realizing what's going on, and good job. 1,000 points, love it. Keep those points coming in. Definitely worth it at the end of the semester for the little bit of bump if you guys need it. And yeah, so if you have questions, feel free to ask. We'll go for a moment or two longer. Can you explain this one right here? Sure. If we are at 2.1, we're right about here on this curve. What's the first number you hit when you go down? You would hit 2. What is above 2? And this is using 95% between. So 5% outside, 2.5% above. And so 2.5% is above here. And then if we go up, we'd hit 3. And what is the percent between -3 and 3? 99.7. Then what is outside of 3? 0.3. Then what's one of my hands worth? 0.15. And that's how you get 2.5 and 0.15. Does that make sense, Ivy? Seeing it right here. And sorry once again, guys, for the delay on the start. I wish you guys could see this setup right now. I've got multiple computers going because I need to be able to see like the chat up here. And so I've got dual computers going. I've got mouse pads and microphones. And so it takes like a 30-minute setup. And then, of course, I had like a 15-20 second latency delay. And that would really, I realized that I just didn't change one setting when and I had to go back in and immediately remake the stream. So thank you guys for bearing with me, and I know the 30-minute delay. I'm sorry about that. We've had like a 5-minute delay before, and I thought that's what we were hitting today sorry about that. But I hope you guys liked this. I hope this helped with some of the concepts. If you have questions, email me. I'm going to be replying to other emails now. But you can ask a question now if you have it. We still got 13 people. But I hope this helped out. I hope you guys better understand the questions, and especially some of the things I hammered down tonight. But if not, if you are typing a question, probably hit enter soon, because I'll probably head off here. And good stuff. You're welcome. You're welcome. Grind. You'll have to tell me who you are in class so we can talk about some. I never played World of Warcraft. I played other online games. I played a game called The Realm, so you could look that up. The Realm is was an online MMORPG from Sierra, and so I know that I know online games can they're bad. They'll suck you in. You'll be playing them 10 hours a day or something. I don't know. It was fun. Now you got me thinking. I have friends who want me to play Elder Scrolls Online. They want me to play that. They're like, Brian, come online, join us. And I'm like, guys, I can't do that. I have girlfriend, I have life, I have job. I can't be playing online video games. I just play regular video games nowadays. And then all my students are like, Brian, play Fortnite. You said you're good at arena games. I'm like, maybe I should play Fortnite. We'll vote on the video game Brian should start playing. Any last questions? I really wanted to play PUBG. Just, that went out of style before I got into it. No, I'm Xbox. And if you after class, if at the end of class you want my Xbox thing, I can give that to you after class. So you can add me on Xbox Live. I'm on Xbox Live. And I actually have a PS3 in this room. It's not hooked up. I think I have something like 22 game systems. I have an absurd amount. I always forget because I'll like go and buy one randomly, like a Game Gear, or I've got like different random stuff. Like I hit mute. There we go. This is a oh, and I knocked the camera. Of course, trip over everything. This is a what you call it, a Virtual Boy. It's a random system. But you guys, everyone's gonna test the Soldier Weekend at the MTV. Awesome, Kyle. Yeah, that was a good fun time. Cool. Well, yeah, I'm wearing down. It's been a long day for me and probably a long day for you guys. So I really do hope you guys have a good test. Is that Charlie from IAS? Sure. Oh, what is that? I do not know. You guys will have to explain that to me. Probably head off here in a moment. But I hope you guys had fun tonight. I hope we learned something. I'm just going to play Virtual Boy. Just put this on my face. And just be playing this. I'll have to check that out eventually. IASIP, Wary Traveler. Oh, It's Always Sunny. Yeah. I haven't seen enough. I think one time I went and visited a friend and we watched like 2 seasons of that over a weekend. I remember watching a lot of it and then I didn't watch any of it later. It was good. I don't know. Sometimes you just don't get into something enough. Dennis System. Well, have fun, everybody. I'm going to end the stream here. I'm trying to think how to do this. You ready? Oh, good night, guys and gals. Email me if you got those questions. See you guys.